Dear students, welcome to virtual classroom of Municipal Corporation of Greater Mumbai. I am Sreekumar. The class is for 10th standard students. Subject is mathematics. Let me begin the class.
Dear students, we are continuing in the same chapter. Last video was a revision of what you have learned in class 9, and it is very important and it is very useful in understanding this part of your textbook, where you revised about the main aspects or things you studied in class 9. Especially you studied about cuboid last year. You know how a cuboid looks like. I'm sure that you know about it. And in the case of cuboid, you are having, I'll just show you, all sides are equal. In the case of a cube, but in the case of a cuboid, you know that it will be having length, breadth, height, most of the time different. When it comes to a cube, you know that when it comes to a cube, it so happens that you will be having all sides equal. Then you studied about cylinder. It was another figure you studied last year and developed the formula for surface area and volume. Then you also studied about cone last year, its surface area and volume. You also studied about sphere, and also about hemisphere. All these things you studied last year, correct? And what you know about all these figures or these structures? You know about the formula to find out its surface area and volume. As far as cuboid is concerned, to find out the total surface area, if I write, you have the formula 2 into LB plus BH plus LH, and you have volume of a cuboid with the length into breadth into height. This you studied last year. Regarding cube, you studied that cube, the total surface area of a cube can be calculated by 6L square and volume by L cube you studied. As far as cylinder is concerned, total surface area including both top and bottom, you had 2 pi r into L plus r. These are all revision. Then curved surface area 2 pi rh. Then volume with the help of 2 pi r square h. Not 2 pi r square h, simply pi r square h, sorry. Volume pi r square h. Regarding sphere, you studied the total surface area. Total surface area of a sphere is 4 pi r square and pi r square, and volume is calculated with the help of the formula in the case of sphere. You studied the total surface area of a sphere is calculated by 4 pi r square and volume by 4 by 3 pi r cube. As far as cone is concerned, the curved surface area, this lateral surface area is pi rl, and if you are considering the bottom also, pi r into L plus r, and if you are thinking about volume of it, 1 by 3 pi r square h. Your 9th standard video which I had posted before this will be very useful to you in remembering all these things. Here the total surface area is equal to pi r square and volume is equal to 2 by 3 pi r cube. So these are the things you studied earlier and you know it well, and you applied this in 9th standard and even in 10th standard just now in the exercise 7.1 which I had asked you to do. So if not done, do it. Make this much very thorough. Make this much very thorough means this much of application very thorough, so that you will be in a position to understand further, and in the board exam you will be having very simple questions to answer where you should be in a position to answer it. Basic knowledge is very important. Okay. As your basic knowledge about mensuration and the formula is clear, what will be the difficulty that you will be facing? I would like to say that there will be a question where you need to apply a little extra common sense to understand. So there can be certain situation where your imagination should be perfect so that you will be in a position to answer. Here is a simple situation. You can see a beaker. Beaker means you can pour water into it. Glass is beaker. Now I am going to put some water into it so that I can tell you some practical situation that may come. Little water is, and consider that this beaker is having measurement on that. This is a beaker of, for example, suppose that it is of 500 ml, suppose. So this will be like, if I divide it like this, it can be 500 ml accordingly. Now I am going to put a ball into this. The question can be something like to find out the volume of the given ball or a sphere, and you are given a beaker, water, etc. So if this beaker is having measurement on that, or if you want to calculate the volume of the sphere, sometime the sphere can be dropped into this particular arrangement where we will be bringing the ball some way. This ball will be dropped into it. I am going to drop it. What will happen is the water will rise. The rise in the level of water will be equal to the volume of the sphere. Suppose that I am dropping it into KCB. Okay, I am dropped it into and the water level raised. So there is, as for example, if it was something like 200 ml here marked, another 200 ml marked here, and as far as here it is 500 ml marked. So we know that earlier it was somewhere here. If I go back, it was a 200 ml luckily. Now it is around 220 ml, suppose. So I will say that 220 ml, sorry, this is 400. So this will be 420. 420 ml minus 200 ml, which is 220 ml, is the measurement we are getting, which is equal to 220 ml is the volume. Milliliter means converting that into the unit of cubic centimeter. So this way we can calculate the volume of a sphere by dropping it into water in a beaker which is having its measurement on that. What we are applying is applying a common sense. There will be many situations in mensuration where you need to apply your common sense in order to solve the problem. We will solve each and every problem in another video. Now let me develop the concept regarding what you have to learn in this chapter. Okay. There are interesting sums in your textbook too. There is a sum, example number 3, which is given in your textbook. A tent of a circus is such that its lower part is cylindrical and upper part is conical. That means you need to draw the diagram to understand how the structure is. Then only you can solve it. Lower part is cylindrical and upper part is conical. So you got two figures over here. One which is connected with our, what do we say, cylinder, another which is a cone. So you will draw a diagram like this. And what they are saying, the diameter of the base of the tent is 48 meter. better draw with a proper tool so that it will look better. Diameter here. The diameter is equal to 48 meter. So I will mark 48 meter here. Then height of the cylindrical part is 15 meter. Height of the cylindrical part is 15 meter. This is cylindrical part. Its height is given. Height will be up to here. And it is equal to 15 meter. Then what more is given? Total height of the tent is 33 meter. That is this height, total height. This is equal to 33 meter. Good. Find the area of the canvas required to make the tent, and also find the volume of air in the tent. So you are asked to find out total, find the area of canvas required to make the whole tent. So naturally, we know that the canvas will be required in all these places. Here it is compulsory because there should not be light and rain coming here. This also, lateral surface also. Then the canvas, there is no need of canvas at the floor. So what is actually asked? Area is asked. Area asked means you will be finding out area of the curved surface area of this cone, for which you are having 48 meter diameter, that means 24 meter radius, same 24 here also. And this total is 33 meter, here it is 15 meter, that means the remaining 15 plus 8, 23 plus 10, 18 meter is the height of it. You can calculate slant height by Pythagoras theorem and you will get L over here. Once you got L, the curved surface area of the conical part can be calculated by the formula pi RL. Correct? So this much is done. Then curved surface area of the cylindrical part. We know that it is, the formula is 2 pi RH. R is the 24 meter, H is given as 15 meter, you will substitute that. So thereby you will be getting 2 pi RH and pi RL together will give you the answer for question number 1. The second question is how much air can be included, as a volume is asked. You know the formula to calculate the volume of a cone, which is nothing but 1 by 3 pi R square H. R is there, H is there. Then the volume of a cylinder is again pi R square H. So you will be calculating this H is only of this H is only of the cylindrical base, this H is only of cone. So my dear students, there is no difficulty, only you need little imagination to apply your common sense and solve the sums one by one, and it is interesting. And it is interesting, there is no doubt about it. So that way you should proceed. I am going to explain you more concept from this chapter. The next topic is frustum. This is a new term for you, F-R-U-S-T-U-M. You have not come across frustum. Actually, the frustum is in fact part of a cone. So always we say that frustum of a cone. So cone you are familiar with, and you have studied about the surface area and volume of a cone. So what is this frustum of a cone? To study that, I should make you familiarize with how a frustum looks like. Let me show you how a frustum is. This is what a frustum is. How it becomes part of a cone, some of you might have got the idea. But if I turn this upside down, we have seen this figure very common in our life. just look like a glass or a bucket, is it not? The common frustum shape in front of us or in our everyday life is simply a glass. But how this becomes a part of a cone? For that I should keep it upside down once again. Think about how to convert this into a cone. For that I need a cone over here, correct? Let me bring a cone and try to correlate it with this. Look, now the second figure I simply attach him with it. Altogether it looks like a cone which you studied in 9th standard and developed the formula of surface area which is equal to pi RL, and you also studied about the volume of a cone is equal to 1/3 of pi r square h, and now we reach to understanding what a frustum of a cone is. Okay, so let us study a little more about frustum. Frustum can be of any size. It can be big. Sometimes we feel that this kind of structure we have seen, see, just like a lamp shade. Sometimes we make this kind of structure to keep something, an idol or something on top of it, right? It may be some foundation of something, of a pillar or something. That means the shape is somewhat familiar to us, but the term frustum is new for you. As the term frustum is new for you, our study about frustum is also new for us. That means normally what we do, we need to understand how to calculate the surface area of a frustum, how to calculate volume of a frustum. For that, lot of experiments need to be, activity need to be done in order to develop the formula to find out these different aspects of frustum. And I am not going to jump into all those activities and make you understand. Instead, when you studied about how the formula of cone, how the formula for finding out surface area of cone, sphere, cylinder, all this we did one after another through activities. Here I am going to provide you directly the formula to find out the surface area, the slant height, then total surface area, volume, etc. of a frustum. Before talking to you about the different formula that we will be using, let me introduce you to certain terms related to it. Terms are very important, just like how you did in other cases. We can say if this is a frustum is having two circular upper and lower part. If you keep in this format, there will be a center to it and a radius. We can say that base radius or bottom radius, and a height from here to here. And naturally, just like in the case of cone, as a part of cone, it will be having a slant height also. So this is height and this is radius. This much we can see very clearly in the case of a frustum. Using this information, we have developed a formula to calculate the surface area and volume of a frustum. But here the upper part, the radius, if you compare with that of radius of the lower part, it will be different. So we can mark the lower one as R1 generally and the upper one as R2. Using this different formula, R1 is normally, we should keep in our mind that R1 is normally greater than R2. R2 is the smaller one. Now, normally we will get radius and height of a frustum. Then first thing we need to know what is slant height. Slant height, in the case of cone we applied Pythagoras theorem. The same way here the slant height, which is marked as L, can be calculated by finding out h square, which is height square, plus R1 minus R2 whole square. This is the formula to find out slant height. If you are thinking about curved surface area of a frustum, that is only not leaving top and bottom, we had pi RL in the case of cone. Here the curved surface area is calculated by the formula pi and L are there, but in the case of R we are having R1 plus R2. Just to remember it easily, I am telling you. If it is a matter of total surface area, where pi R1 square and pi R2 square will be added into it, naturally the formula will change into the original formula of curved surface area will remain like that, plus you will be having pi R1 square plus pi R2 square. And as far as volume is concerned, we had 1 upon 3 pi r square h in the case of cone. Here also 1 upon 3 pi h is remaining as it is, but in the case of r square over there, we need to have r1 square plus r2 square plus r1 into r2. So you may think that sir, have explained each and every formula, how the formula derived, how did we reach to this formula of slant height, curved surface area, total surface area, volume in each and every case previous. Here I am not explaining you that because that is not expected, that because by this time you are 100% sure that formulas are derived very scientifically and properly, either through mathematical approach or through some activities or through by some observation and conclusion. So be very clear about different formula used for finding out slant height, curved surface area, total surface area and volume of frustum of a cone. What need to be taken care is that whenever you are doing sums related to solid geometry, which I say, you should have clear-cut imagination about what the structure is, how it looks like, and what is asked. Secondly, you should be very, most of the places there is the unit of pi will be given. Sometime it will be 22 upon 7 given in the question. Use that. If it is given as 3.14, use that, because it is given with a purpose of solving the sum with mutual cancellation on other side. Thirdly, whenever you are doing sums related to this kind of question, you should be very sure that the units used, like centimeter, millimeter, liter, whatever units are used should be same, or you should normalize it, make it common, so that the answer will be more accurate. Okay, so these are something which I would like to tell you at this moment, where your idea about frustum is limited to how it looks like and what are the different formulas. Please be very clear about it. The next topic is sector of a circle. Circle is known to you, and I mentioned about sector in the last video when I was trying to explain you how the curved surface of a area of a cone is derived. That was in the last video. Anyway, sector is a term connected with a circle, and you are familiar with circle. Now what I have to make you understand is what is a sector of a circle, and as well as how to find out area of a sector of a circle. So let me first of all make you understand what is sector of a circle. For that I need a circle. From circle we can go to sector of it. You know this is a circle. And you have studied all important properties related to circle. What all you have studied related to circle? Related to circle, you have studied about the concept of center of circle, then from the center, the radius of the circle, then you have studied about the diameter of a circle. All these things you have studied, and now you are going to learn about sector of a circle. In order to develop sector of a circle, you will be dividing the area within circle into two parts. It is created, in fact, from the arc formed, then another thing comes, what is an arc? The next thing that you need to get familiarized with is sector of a circle. Circle you are familiar with. You have studied a lot of properties of circle by this time. Mainly, whenever you think of a circle, you remember about the center of a circle. Then you also remember about the radius of a circle, right? Which you draw from the center to the circle. Then you also remember about diameter of a circle, which is double of radius passing through the center. And you also know about diameter is a chord. Chord is that particular line segment touching 2 points on the circle. You have studied a lot. You also studied about tangent to the circle. You have studied about a lot of things. But here, what is sector of a circle? Sector of a circle is an area within circle formed between two radii of it. Means, suppose this is a circle and I am putting this as center of it approximately. Now I am going to draw radius of this circle, more than one, then it will become radii. To draw that, I am drawing one over here, another over here. So now you can say that within the circle I have drawn 2 radii and there is a part which is enclosed by it. The word should be something like enclosed. If I think one way, I can say that this part is enclosed by, this is, one second, this is one radius, this is another radius. I can say that this part is enclosed by the 2 radii drawn. This enclosed part is called sector. So what about this? That is also sector. If you look in that way, this particular radius and radius is enclosing this part. So in fact, when we think about 2 radii and the part enclosed by those 2 radii can be named as sector. In that case, one is small, another is quite big. One area is less, another is a quite big area. So we need to say something in that angle, in such a way that when the area is less or when it is made by a small arc, then comes another term, arc. This is a small arc, otherwise called minor arc. That area is named as minor sector. It's all naming only. Minor sector, and this can be named as major sector. This is the primary information that I would like to give you. When you think about how to name a sector, center is common for this. Suppose that if I am writing over here P and Q and there is an angle theta here, so I can simply say that by putting a point over here like something like M, if I want to mention this small a minor sector, I would say that in the figure PMQ represents a minor sector, where O is the center. I represent it like this. On the other hand, if I put a point over here and mark it as B, I will say PBQ with center O is representing a major sector. This is what is naming of a sector. Sector, whether the sector is minor or major, depends upon the area. Okay, so in that case, on what the area depends on? area depends upon the position of these two radii. If there was no any such separation, that circle had its own area. So I would like to draw another circle now, which will help me to explain you little differently. Suppose that there is a circle like this, and we know that the circle has got its own area, and we calculate the area of a circle with the formula pi r square, correct? This is very much known to us right from class 5. Suppose that if I draw a diameter to it, the diameter I am going to draw within the circle through the center, a diameter. Chalo. The circle is divided into two. But just now we understood that if this is the center of the circle and this is R, this two radii making the circle into two area, minor sector, major sector, no. Both are equal sectors there, having equal area. That means if you ask me, or if I ask you what is the area of this particular enclosed part, you will say that if it is like this, the way it is shown, you will say that it is half of pi r square. No doubt about it. Suppose that if I make one more diameter, the circle will be divided into 4 equal parts within, and 4 sectors will be formed, and all 4 sectors are of equal measurement, and then I would say it is having a measure equal to 1/4 of pi r square. No doubt about it. So what is actually happening is the sector size is decreasing by dividing the circle into small sectors. If I put one more, again it will reduce. But the pi r square will keep on reducing. So area of circle will be connected with sector depending upon what kind of sector is formed. And the kind of sector depends upon the angle of the sector formed. The angle of the sector, we know that the total is 360 degree. For a 360 degree, the area of the circle is pi r square. When it was divided into 2 by a diameter, it became 180 degree, we got half pi r square, correct? Right? When it became 90 degree, like this, we wrote 1/4 of pi r square. So there is a relationship. That means this is 1 pi r square, half pi r square, quarter pi r square, or 1 pi r square, 1/2 pi r square, 1/4 pi r square. So 90 degrees should give 1/4. That means we are in a position to understand if theta is the degree which we are considering as the degree which is the measure of the sector or central angle created by these two radii. So if you are dividing theta with 360 and write pi r square, the formula will become right. For example, if it is 90/360 pi r square, it is equal to 1/4 pi r square, the way we just got. So my dear students, we could develop a formula to find out area of a sector. What is the formula? The formula just derived is theta upon 360 into pi r square. Remember this. You know what is a sector? A sector can be of any measure, any central angle measure. Depending upon that, the area of the sector. Depending upon that, we classified sector into minor and major. Within minor, there can be more, smaller, bigger. But the area can be calculated by the formula theta upon 360 into pi r square. And how a sector look like, I would like to show you once again, because that images in this kind of situation, images are very important. This is a circle, and if I try to divide this into 6 pieces, each part in this is a sector. This is the shape of a sector, and each sector will be having its own measurement, an angle here, which we named as theta. This is an arc. There is a topic, another topic you should understand. The arc. Arc is created out of the circumference of our circle. I'll get into the arc topic now. Before that, please understand, this is sector, and the area of sector is calculated by the formula theta upon 360 into pi r square, where you only need to know the angle and the radius of the circle of which the sector is a part. Okay, so let me move to the last and final concept that you have to study this year. Maybe the last topic as a fresh topic to introduce to you is about arc and length of arc. Arc and length of an arc. I think you have a fair idea about what is an arc. We just came across arc while explaining about what is a sector. Even then, arc is part of a circle. Sector, if sector is talking about the area of a circle, arc is part of a circle. This is a circle. When you divided the circle into sectors, you got sectors like this, right? Within that, we can have a part of circle looking like this, which is named as arc. This is arc. The size of the arc, it can vary. It can be small, it can be big, it can be as big, or it can be completing the circle itself. It can complete into a circle if extended. It can be of any size. Just like the sector, it can be small, big, but it will be having connection with the circle of which it is a part. That is very important. The radius of the circle is the radius of the arc itself. The radius of the sector also important. And when we developed a formula to find out the area of sector, just now, we developed a formula theta upon 360 into pi r square, right? To find out the area of a sector. As far as arc is concerned, arc is part of a circle, so there is no concept of area because a circle is made up of points. But we can talk about the length of an arc, or we can think about length of an arc. When we think about length of an arc, let me draw another circle here, and I am going to bring out an arc out of this. So from this I can just develop an arc like this, and the arc can be big, and it can even complete a circle. 347 degrees of measure of the central angle created by this arc. What does it mean? If I draw means I can draw and show you. I'll draw and show you. Suppose that if I am drawing an two radii over here, that measurement it is showing. The measurement of the angle created by those 200 and 221 degree. That angle created by these two radii at the center. The other part will be out of 360, 220 here, 140 will be the other side. So this way an arc will be having a central angle. And if you think about the length of the arc, which is our topic, the length of the arc or length of an arc, as it is part of the circle itself, maximum it can be 2 pi r, then it becomes a circle. If a small part of the circle is missing, the arc will be less than 2 pi r depending upon the angle. Just like sector, arc is also depending upon the central angle. That means if the measure of the central angle is 360 degree, the arc will be having a length equal to 2 pi r. In this case, as we have taken diameter over here, it will be having a length equal to half of 2 pi r. If I divide further here, this will be having a length equal to 1/4 of 2 pi r. That means in order to get half, it will be 360 degree, which is basically 2 pi r. In order to get half over here, we need 180 divided by 360 here. In order to get 1/4 here, 90 divided by 360. The same story like that of sector is repeating. So the formula also will be in the same way. Theta upon theta upon 360 into 2 pi r will be the length of an arc. So there is a close relationship between the formula of area of a sector and length of an arc. Theta upon 360 into 2 pi r. So my dear students, lot of formula, lot of figures together came in this chapter, but nothing to worry. You need to be very cool and read the questions thoroughly and imagine what they are trying to ask or what they means, people like us or the board, and draw a proper diagram and start doing it. And as I always told, check the unit, use what all information given in the question and copy it into the rough diagram you are drawing, so you will be very easily solving the situation. So just for rewinding, cube, cuboid, cylinder, which you studied in detail in 9th standard, sphere, hemisphere, that also you studied in 9th and now revised in 10th standard. That is what happened in the last video. Then the new entrant or the new topic which you learned, the concept of frustum, and the just now learned concept of area of a sector and area of a sector, and the same way length of an arc. This is what you studied altogether in this chapter, mensuration. Full of figures, full of formula. And read the question thoroughly, convert the question into proper diagram, substitute the data given, think for a while, check the units, apply all the information given in the diagram and apply the formula. 100% sure you will get the answer. Thank you. Now click on the subscription button below
to subscribe the channel, then the bell button to get the notifications of the new videos. Thank you.